Hello friends, myself R.D. Mahajan presenting my video on successive differentiation part 3. Prove that nth derivative of e raised to x into sine of bx plus c as equals to r raised to n e raised to x sine of bx plus c plus n phi, where the value of r is root of a square plus b square and phi is tan inverse of b by a. And therefore to prove this, we try to find out successive differentiation. Let given expression as y e raised to x into sine of bx plus c. It is a product of two terms of x. Therefore, when we differentiate it with respect to x, first time we have to apply a product rule. Therefore, y1 is equal to first term e raised to x, derivative of sine is cos of bx plus c into b, chain rule, differentiation of bx plus c is b, plus second term as it is, that is sine of bx plus c into differentiation of e raised to x, derivative of e raised to x is e raised to x into a. Whatever the common term, we take it outside. Therefore, e raised to x is common term. Remaining terms are b cos of bx plus c and plus a sine of bx plus c. We call this as equation 1. In this equation 1, we introduce right angle triangle in such a way that tan phi is equals to b by a. Therefore, opposite side is b and adjacent side is a. Then only we get tan phi as b by a. And this hypotenuse is root of a square plus b square from the geometry of that right angle triangle. And then we try to find out value of sine phi with the help of that figure, right angle triangle. Sine phi is b divided by r. It implies b is equals to r sine phi, and cos phi as adjacent side divided by hypotenuse. Therefore, it is a by r. We get the value of a as r cos phi. Substituting these values of a and b on the right hand side of this expression for the constant terms only, or not the function of x. Therefore, that e raised to x as it is, y1 is equal to e raised to x as it is. B, the value of b is r sine phi into cos of bx plus c as it is, cos of bx plus c plus a, the value of a is r cos phi into sine of bx plus c, sine of bx plus c. From this two term I can take r common, therefore r e raised to x, remaining terms in the form of sine a cos b plus cos a sine b. By standard trigonometric formula, it is nothing but sine of ax plus sine a plus b. Here a is, suppose we consider as bx plus c, and that b is phi. Therefore, by differentiating with respect to x, first time we get this is the value of r, value of y1, where r is root of a square plus b square and phi is tan inverse of b by a. And therefore, again differentiating it with respect to x, and if we repeat the same procedure, means differentiating this by product rule and then substituting the values of a and b, we get similarly y2 as r, y2 is equal to r square e raised to x sine of bx plus c plus 2 times phi. For third times it is r cube e raised to x sine of bx plus c plus 3 phi, and so on. If you continue it n times, we get nth derivative as r raised to n e raised to ax sine of bx plus c plus n times phi, where the value of r is root of a square plus b square and the value of phi is tan inverse of b by a. A required result. Okay, therefore remember this as a standard rule. Nth derivative of e raised to x into sine of bx plus c as r raised to n e raised to x sine of bx plus c plus n phi. Similarly, we have another result. Second result, nth derivative of e raised to x multiplied by cos of bx plus c is equal to r raised to n e raised to x cos of bx plus c plus n phi, where same value for r root of a square plus b square and phi as tan inverse of b by a. Therefore, exactly on the same line, try to get the result. I will not discuss that proof here. Do it yourself. And then remember this as two standard result to find out the nth derivative. Then some simple examples on this. Therefore, first example, if y is equal to e raised to sine of x, find its nth derivative. And therefore, to find the nth derivative of this term, which is similar to e raised to x sine of bx plus c, comparing we get here coefficient of x in this term of e raised to x, that is 1, and sine of bx plus c, coefficient of x in this term of sine x, therefore that is also 1, and then we get the value of r as root of a square plus b square. It is root of 1 square plus 1 square, therefore it is root 2. And then phi as tan inverse of b by a, it is tan inverse of 1 by 1, tan inverse of 1 is 45 degree, that is pi by 4. And then taking the help of this result, we get therefore nth derivative of y as yn and nth derivative of right hand side term as nth derivative of e raised to x into sine of x is equals to r raised to n, here r is root 2 raised to n, e raised to x, that is e raised to x, sine of bx plus c, sine of x, plus n times phi, phi is pi by 4. And therefore, this is nothing but root 2 means 2 raised to 1 by 2, and that raised to n, it becomes 2 raised to n by 2 e raised to x sine of x plus n phi, phi is pi by 4 as the required nth derivative by applying this first result. Second example, if y is equal to e raised to 2x into cos of 3x. Once again, the term is in the form of e raised to x cos bx plus c, and to obtain that nth derivative, we try to apply this result. Therefore, given y is equal to e raised to 2x into cos of 3x, comparing this term with this term, we get here the value of a, coefficient of x in this term, that is 2, and cos of bx, b is coefficient of x, that is 3. After getting the values of a, b, we get the value of r as root of a square plus b square, a square 2 square, b square 3 square, 9. Therefore, 4 plus 9, we get root 13 as the value of r, and phi as tan inverse of b by a. The value of b is here 3 and a is 2, and not a standard term or standard value, therefore we keep this term as it is. And then Taking nth derivative on both sides, we get yn is equals to nth derivative of e raised to 2x into cos of 3x. Applying this result, it is r raised to n. R is here root 13 raised to n, e raised to x, e raised to 2x into cos of bx plus c plus n phi. It is 3x plus n phi. Phi is tan inverse of 3 by 2. That is the result of, we can rewrite it as 13 root 13 means 13 raised to 1 by 2, and that raised to n, it becomes 13 raised to n by 2 into e raised to 2x cos of 3x plus n times tan inverse of 3 by 2 as the answer of the required nth derivative. Third and last example, if y is equal to e raised to x multiplied by cos x into cos of 2x, here we have a product of three terms. Last two terms in the form of cos x into cos of 2x. Therefore, to obtain it, we have to convert either in this form or in this form. Therefore, for that, I will rewrite that term e raised to x cos x into cos of 2x. That product of two terms of cos, I will convert into sum by applying defactorization result. For that, we have to multiply it by 2 and divide by 2. Therefore, it is e raised to x cos x cos 2x. To this term, I will multiply by 2 and divide by 2, so that no change in the value, only form I have changed, and therefore it is 1 by 2 outside constant term e raised to x. Then applying 2 cos a cos b is nothing but cos a plus b plus cos a minus b, and therefore it is cos of a plus b x plus 2x, we get 3x, and plus cos of a minus b x minus 2x, we get minus x. Okay, which formula I have applied? Here we know that 2 cos a cos b is equal to cos a plus b plus cos a minus b. Using this result, and therefore simplifying it, we get y as 1 by 2 e raised to x multiplied by cos of 3x and cos minus theta. Cos of minus theta is cos theta, and therefore it becomes cos of x. Means we have two terms. If we multiply it inside, the 1 by 2 e raised to x into cos of 3x and e raised to x into cos of x. We call this equation 1. Nth derivative of this y means nth derivative of this y. Therefore, we try to find out nth derivative of the first term and then nth derivative of second term, and then adding that to nth derivatives. Taking nth derivative on both sides, therefore nth derivative of y is yn, 1 by 2 constant term, nth derivative of first term plus nth derivative of second term. Symbolically, I can write that as e raised to x into cos of 3x plus nth derivative of that e raised to x into cos of x. Okay, and then comparing this first term with this term, we get the value of a for first, it is 1, and b coefficient of x as 3. We get the value of r as root of a square plus b square, 1 square 1, 3 square 9, it becomes root of 10. And phi as tan inverse of b by a, it is 3 by 1. Similarly, we try to find out for second term. A is 1, b is also 1, coefficient of x in this second term. The value of r is root of a square plus b square, 1 plus 1, it becomes root of 2. And phi as tan inverse of 1 by 1, tan inverse of 1 is pi by 4. And therefore, applying this result, we get yn is equal to r raised to n, 1 by 2 constant term, we keep that as it is. R raised to n for the first term, it is root 10 raised to n, e raised to x, cos of bx plus c plus n phi, cos of 3x plus n phi, phi is tan inverse of 3. This is the first term, nth derivative of the first term. Then nth derivative of second term, by using this values, we get plus root 2 raised to n, r raised to n means e raised to x, here it is e raised to x, cos of bx plus c, that is x, plus n phi, value of phi is pi by 4, therefore n times whatever the common, we can't take here any common term, therefore this is the required answer or required nth derivative. Only remember this first step, that product we have to convert into sum by applying defactorization result. For that we have to multiply it by 2 and divide by 2, and then we get two different terms. Find the nth derivative of first term, find nth derivative of second term. For that, try to get values of a, b, here also values of a and b, then find the value of r, find the value of phi, find the value of r, find the value of phi, and then use this result. Therefore, in this I have discussed standard result for nth derivative of e raised to x sin bx plus c, and standard result for e raised to x cos of bx plus c, nth derivative of that term. And then I have discussed 3 simple examples based on that formulas. One more standard result I will discuss in my next video. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you for watching.